It's important to be able to simplify radicals. If we have something like a basic number, such as the square root of 16, we know we're looking for the number that we can multiply by itself to get 16, which does indeed come out to be 4. We have to know what to do when we have things under the radical other than a constant. I have listed here 5 rules that you need to follow when simplifying radicals. We're going to deal with 4 and 5 in a later video, but the first thing we're going to deal with is rules 1, 2, and 3. The first thing you need to recognize is that if we're dealing something like this, perhaps the 4th root of a to the 8th, notice rule number 1 says there can be no exponent under the radical greater than the index. Well, the index is 4, and under the radical is an exponent of 8. So what you can do here is you take the exponent, 8, and you divide it by the index. 4 will go into 8 twice. 2 times 4 is 8. There's a remainder of 0. This number tells you how many A's to pull out, and this number tells you how many to leave under the radical, in this case, 0. So the 4th root of a to the 8th power is simply a squared. Let's look at one that's a little more complicated. Consider something like the cube root of 16a to the 8th, b to the 9th. We're going to deal with constants last for rule number 3, but here we're going to take 8, the exponent, and divide it by the index. 3 goes into 8 twice. 3 times 2 is 6, leaving us a remainder of 2, which tells us we're going to pull out 2 A's. That comes from here. And then under the radical, we're going to leave 2, and that comes from here. The b's, we're going to take the index and divide it into the exponent. 3 goes into 3 3 times with a remainder of 0. So we're going to pull out 3 b's, and we're going to leave no b's underneath. Step 3 tells us to factor any constants and group them by the index. So here we're going to take 16. We're going to factor it, and there's several ways you can factor it. I'm going to factor it as 2 times 8. 8 can then be factored into 2 times 4. I can factor again, and that factors into 2 times 2. And when I say group by the index here is 3, so I'm going to break it into groups of 3. This tells me there is one group of 3 that I'm going to pull out, and one that will remain underneath. One group of 3 gets pulled out, and there's 1, 2 left. So the final answer for the cube root of 16a to the 8th, b to the 9th is 2a squared, b cubed, times the cube root of 2a squared. The only special circumstance that we do have to deal with is sometimes we need to be concerned if it's an even root that we're simplifying by. We've already talked about the fact that we cannot take the even root of a negative number. So when this happens, if you have an even root and you pull out an odd exponent, you must put that odd exponent in absolute value. As an example, if I have the 4th root of 32 x to the 5th, y to the 8th, z cubed, again, I'm going to take each of those exponents and divide it by the index. 4 goes into 5 once with a remainder of 1. So I'm going to pull out 1x, and I'm going to leave 1x inside. I'll take y's next. I'm going to do 4 into 8, goes twice with a remainder of 0. So I'm going to pull out 2 y's and leave none underneath. And notice 3 is already less than the index, so my z's remain as they were. And then I have to factor the 32. This time I'm looking for groups of 4. So here I've got 16 times 2. This factors into 4 times 4 times 2. These each factor into 2. I have one group of 4, So I'm going to pull out 1, 2, and I'm going to leave 1, 2 remaining. So my final answer is 2xy squared, the fourth root of 2xz cubed. But as I stated before, because it was an even root, if I pulled out an odd exponent, which I did with the x that had an exponent of 1, I must put it in absolute value to make sure that I'm not trying to take the even root of a negative